All right. Hi, everyone. My name is Jason. That is the fastest way to send a hermit back to Tennessee if I've ever heard one. Today I'm going to talk a little bit about the SQLAlchemy ORM. And just to give you a little warning ahead of time, I'm mostly going to talk about cookies. I could probably stop anytime, but no, it's not really. I'm pretty much going to talk about cookies the whole time. And occasionally we'll write something to a database. I'm also keenly aware that it's terribly unhip to actually write to relational databases or whatever. I'm okay with that. Look at me. I am a model definition for trendy, right? So talking about SQLAlchemy, there are really two huge components to SQLAlchemy. One of those is the core, which is very schema-centric. So it's focused around objects and schema pieces of the database, right? So it looks at tables and columns and expresses things in that manner and interacts with them in that manner. But what we're going to look at today is the ORM, which really works around business models or user-defined models that you create, right? So installing SQLAlchemy happens to be super simple on most platforms, including Windows, thankfully, thanks to Wheels. So you can pip install SQLAlchemy, and that will give you a working version on pretty much any system. If you do have a problem with this, there is a way to do it without C extensions. That's pretty easy to Google if you have a problem on Windows or some obscure BSD system. So the first thing I want to talk about is getting actual access to the data. So I want to connect and establish a session, and we'll talk more about a session in just a second and give you some details about what it does. So to start on that process, and hopefully people can read my code samples. I know the colors wash just a touch on the display, so I tried to pick some bright things. To start off, the first thing we need to do is create an engine, and an engine basically defines the database tool that we're going to use to connect. So in the Python world, we call that a DB API, but it's basically the way that we're going to go talk to the database, and then it defines where that database is. So if we look at the create engine here, we're basically telling it we're going to use the SQLite built-in database API, and we're going to talk to an in-memory SQLite database. So if this were going to talk to Postgres, I would write, or Postgre, depending on how trendy you are, I'd write Postgres here and then give it the user :password at host kind of syntax in that same region. Does that make sense? So it's essentially a connection string that defines what database API we're going to use to talk to the database. Now that we have an engine, we're actually ready to establish a session. So sessions are really the most kind of powerful part of the SQLAlchemy ORM. And these 3 lines of code are very misleading as to what's actually happening under the hood. The session wraps the database connection that we created with that engine, and then it provides this identity map that connects the objects that we're going to create to that session, right? And then ultimately relates them to the objects that are in our database, right? So the rows. So this is a way to take, we're going to talk a lot about cookies, so this is a way to take a cookie object that I created in my application and marry it to a row that contains the data for that cookie in a database. Does that make sense? So the session is going to be responsible for making that identity map between those two things. And it sounds really complicated, but they're just using the primary key to connect those two things. So we attach that primary key to our object, and it reflects the primary key that's actually in the database itself. And then the last thing that the session does is actually wraps transactions around what we're doing, right? So, and we'll look at this in detail when we run the very first example, but when we've created this session, nothing actually has happened yet. There's no connection to the database actually active. There's no transaction active. It's just sitting there waiting for us to do the first thing, right? So this session is the way we're going to interact anytime we want to go into or out of the database. It's kind of our gateway to that data. Does that make sense? The next thing we want to do is actually like define some models to store some stuff. This is quite possibly my favorite coffee cup ever. It actually holds cookies under the coffee, and if you get the coffee hot enough, the cookies stay warm. It's like genius. Like this is what we were supposed to be figuring out when we started writing software. Like, right? What the heck? All right. So the way that we define these user models and connect them into the database is by using this thing called a declarative base. And there's a lot of complicated stuff that goes on in declarative base. It's actually pretty readable, but it's really not the topic for what we're going to cover here. You can literally know these 2 lines about the declarative base and know all the things that you really want to do with it in most cases. So here, we're just simply going to import the declarative base from the SQLAlchemy extension, and then just create an instance of it by just calling that declarative base. Now, here, I've took the very most naive version of that object, and in fact, most people actually take a very naive version of that object. So this base equals declarative base, you'll see that all over the place in things like Flash SQLAlchemy or in Pyramid. Like you'll see it repetitive in different applications that use SQLAlchemy because while you can pass things into there, the defaults are really, really sane, right? So a lot of people end up using it straight like that. So once we have a declarative base and we have a way to talk to the database, so we have a session, we have a base, now we're ready to create a thing that we want to store. I want to talk about cookies, not lying. So here's my cookie model. Basically, anytime we create a model for SQLAlchemy, it has to have essentially 4 properties. Those 4 properties are pretty straightforward. One, it must inherit it from the declarative base. So here's my declarative base I created earlier, right? The second is it has to have a underscore table name. That actually tells us where in the database are we going to store this, right? So when you say create an instance of cookie and then store that instance of cookie, where do I actually do that in the database? That's what the table name is connecting together there. Then it has to have 1 or more columns. So in this case, we've got several for storing our cookie information here. And then let's talk about those columns for just a second. So how many of you have ever used SQLAlchemy before? So a lot of people are getting a review. But if you've never used SQLAlchemy before, essentially what we're doing here is defining the column type and then any extended values of that column, right? One thing to note in here, you'll see a lot of people just do string and then just put parentheses without a number in there. That's very dangerous. Different databases don't take nothing as a reference for strings, so you want to give it a length explicitly every time. Just because you get away with it on your system doesn't mean that the following upgrade won't. A good example of that happens to be MySQL. Depending on which version you run, it will or will not take it with or without. But then we pass extended attributes to that same property. So here we're defining this one to be a primary key. This one we're saying we want to build an index of. And that works. It actually goes and creates a database index on the backside when we do that. So does this seem pretty straightforward? Essentially, we're defining a base that has, an ID, a name, a recipe, a SKU, and then some quantity and some unit cost. And I called them cookie underscore ID. You could just call it ID. There happens to be an ID keyword, and I just don't like that collision. That's why I name it that. So the 4 things, again, must inherit from the base object, must define a table name, and then must have 1 or more columns, of which one of those or multiple of them define a primary key. Does that make sense? So those are the 4 things that you have to have for a complete ORM object. And then, of course, the next thing we want to do once we've created our model is actually go create the table behind that, right? So to create the table, we're going back to that declarative base. Now that declarative base, I didn't go into this a second ago because I said it's pretty straightforward and pretty simple, but it holds one really kind of critical piece of information, and that is the metadata. The metadata is actually a catalog of all of your user object column information and then all of your table schema information kind of in a way so it can line them together, right? So here we're telling base, take your metadata, go create every table, essentially, that you find in there against the engine that we created at the very beginning, right? So this is actually going to create our cookies object in our in-memory SQL database. Cookies are fleeting, they get 8, so memory is a good place for them. All right, so now we're going to insert some data. All right, so let's start by adding a cookie. So here we're going to create an instance of our cookie class. Now one other thing that the declarative base gives us is this automatic, out-of-the-box, under a init, right? So like if you were defining a user class, a lot of times you would want to define an under a init so that you can tell it, hey, the name maps to this position and the argument when I create it, that kind of thing. The declarative base actually maps every one of those attributes into an automatic under init method, right? So that the constructor is already built for us. We get that by default just from inheriting from declarative base. So here we're creating a cookie, chocolate chip cookie. Not my favorite, but we'll start there because most people understand it. Awesome recipe for a cookie. It's got a SKU because I'm going to create a shop eventually, and then how many and how much. I have expensive chocolate chip cookies apparently. Once we've done that, we're ready to leverage that session, all right? So when I create that cookie, it's just hanging out and hasn't really done anything yet, right? It's just an instance of a user data object. Once I actually do session.add here, that actually pulls that cookie information and puts it into the session, right? And once the session's attached to it, it's ready to go or talk to the database. Because it doesn't have a primary ID yet, or a primary key yet, which in our case was cookie underscore ID, because that doesn't exist yet, it knows this is a new record. Does that make sense? So because this is a new record, adds it in there, and then when I call commit, it actually flushes that record to the database, which means it creates that row. And then the next thing it does is actually perform the final commit. And then the ID will be retrieved as a result of that final commit and attached to that cookie instance, right? So if I was to go access any attribute of that CC cookie, for example, now there would be a CC cookie dot cookie underscore ID. Does that make sense? So again, there is. I assigned a primary key. Yes. Yep. Automatically creates a sequence, does those things. Now you can get fancier if you want a very specific sequence structure. You can define your own. Like I could have went into that column and actually called in a PG func to create a special sequence if I wanted to define one. But by default, it will create one on its own. Yes?
Is it possible to create a cookie outside of Python, just go to database create directory and use it?
Absolutely. And remind me at the end, I'll talk more about that. Did you have a question? Okay. All right. So we have a cookie. We've added it to the session. We've committed the session. Let's talk about what really happened on the back end, right? Because this all seems like way too much magic. So what actually happened in our database was we added the cookie to the session and nothing happened. But when we called commit, we made a call to action, right? So that commit actually began as a transaction. That's essentially what you're seeing there. Then the very next thing it does is create an insert statement to insert that data into the cookies table. And then it passed in all the parameters that would fill that query. This automatically creates a flush in most databases, basically everything but Oracle. And then we called a final commit that actually, the flush writes the record into the table. The commit actually says, I'm done with the transaction. I'm not going to do anything else. As long as this passed, move on, right? Does that make sense? This is what happened when we did the add, or when we called commit. So started a transaction, inserted the data, and then committed the transaction to close out what we were working on. Yes?
Is there any way to explicitly define when I want transaction start?
Absolutely. By default, this pattern is pretty much prevalent in all ORMs. It's called the unit of work pattern. So a call to action results in one unit of work, which is always wrapped in a transaction. But if you need to do something more complicated, you can actually, on the session, manually begin or even nest transactions if you want to. Yes? Sure. Absolutely. And not only, you don't have to commit every transaction, right? You can also just do flush. Are people familiar with database flush? I'm sorry, I should have asked that ahead of time. Shake head yes or no. Want me to explain? Okay, so in the database world, in the old database world, before documents were a thing and where you were just like stuck stuff in a thing and pretended it was okay, whatever. I'm old, I can't help it. So in the old days, right after we got done killing dinosaurs, we decided that commit is intensive, right? Commit actually means multiple things. It means do whatever action I told you to do, verify that action occurred, then close down everything about that transaction and release the memory about it, right? Flush doesn't do that. Flush says, write a transaction, clear the memory. I'm going to believe you it happened, right? That's actually, you can go in instead of saying session.commit, I can do session.flush and just clear out what I was working on at that moment. Does that make sense? So that's kind of the difference between a flush and commit. And there's a whole world of database theory difference behind those two. I'm greatly summarizing that. That's kind of my thing. Doesn't have to be as complicated as we make it sometimes. So I made mention that automatically would go and refresh the data of that object. So when I did the session.commit, CC cookie now has its cookie ID, right? It happens to be the first one I added to the table, so it's ID 1. Does that make sense? Now, another thing that you can do, you were talking about commit is heavy. Absolutely. Unit of work is actually really heavy, right? If you think about it, beginning a transaction for something as simple as inserting a single object could be really heavy, especially if that single object suddenly becomes hundreds of thousands of objects, right? So bulk insert is a way to get away with this. So here I've defined two cookies, peanut butter and oatmeal raisin, go peanut butter. And what I'm going to do is I've actually called session.bulk_save objects here and then passed it a list of objects. You can actually do some crazy things. The people at Continuum.io have created this thing called Odo, where you can actually just take a pandas thing, pipe it into Odo, pipe it into there, and just dump an entire pandas data frame into a table, which is pretty excellent. So interesting thing about this, when I call commit, this isn't attached to the session. And I know that doesn't make sense. Notice I didn't add C1 or C2 to the session. I just said, session, go save these objects. I'm not planning on working with C1 or C2 anymore after this. And so when I call session.commit here, a transaction occurs, but it's a single transaction for both of those inserts. It could be hundreds of thousands of inserts. I've seen it do 1 million and not even flinch. But interestingly enough, if I call that C1.cookieID, I'll get nothing back. Right? Again, not attached to the session. We're not refreshing the data. We're not responsible for what's going on with it. So we get a great speed increase because we're not committing the transaction every single time we do anything. But there are other trade-offs to that, right? One is that we don't really respect any related data objects, and we'll talk more about relationships in a second, because look at me, I'm a relationship counselor. Objects are not really connected to the session. So again, we're not going to refresh their data from whatever changes we made into the database. Also, primary keys, as you can see, are not fetched. And then no events would be triggered. So SQLAlchemy has the ability to tie into on commit or on pre-commit, all these different hooks that we can tie into. This doesn't trigger any of those. Any questions about insert, bulk insert? Yeah.
So here's about insert, here's one transaction fail, so it comes after fail and goes back.
That's your decision. So you can decide, I want you to flush individually on them and then look and see, because a flush will trigger an error from the database side, right? So you can decide if you want that to happen, but in general, when you're putting something in via bulk, it's your responsibility to get the data in the correct format. So if you force it to do flush, you're going to give up a lot of that speed. Yes, sir?
So without actually saying that you're distinguishing bulk save with add all?
Add all is, yeah, I would not use that method. Add all is great if you're wanting to take a bunch of things that are already, like, were formerly attached with a session, or maybe were attached with a different session, or pull them across a little different vernacular. I wouldn't use them in the same manner. Does that make sense? All right, so let's talk about queries. Deep thoughts. And again, all the cookies. So the first thing I want to do is find out what all cookies do I have in my database. So the very top line up here is exactly that. Again, I'm going against that session. I'm saying, hey, session, issue a query statement against the cookie object. Give me all the rows in that, right? And then I'm just going to print cookies. Now, to get your cookies to look like this, you have to create a repr, an under repr. Or, do you guys familiar with that? So under repr is basically says what representation do you want returned, and the Python manual says that that representation should be something you can copy and paste and create another copy of that, right? So the idea being is that you could copy and paste one of these entire entries, and it would then give you that instance of the cookie, right? So here's an example of that. So we queried the cookie object and then .all. There's another way that we can do this. We don't typically, I don't know, in your world, you might pull all those data out and put it into pandas, or pull all that data out and run some NumPy across it, but a lot of times we're going to want to iterate through things one result at a time, or interact with one result at a time. So here, I'm doing the exact same thing, except for I'm going to use an iterator and not call the .all method. So .all actually forces every single result to be created up into a list. Here I'm going to treat it like it's an iterator, so session.query, and then I'm going to say for each cookie in, or if it's helpful to you think less, each row in, either one of those works, then print that, right? So that then prints the list of cookies the same way. Yeah?
I missed that. Where does the ID show up then at least
Right. So in my repr, I just didn't have an ID, because the idea is that I should be able to select this, copy and paste it. So the ID column is normally left out of those, but it's there, I just don't have it. Does that make sense? So I could easily come in here where I'm saying print cookie. I could say print cookie dot cookie underscore ID, and it would then print the IDs. And in fact, we'll do that in just a second. And you probably know we often don't want to be dealing with entire objects. We want very specific parts of those objects that we want to interact with, right? So in this case, what I'm doing here is a session.query to get the cookie name and the quantity. Then I'm saying, give me the first. So first is an interesting thing here. First is, give me whatever, run all the results, give me the first one of those or give me none, right? So it's okay if there's not any. It's okay if there's many, just give me the first one of them, right? And I'm just printing that. So in this case, cookie name and quantity are printed out as a tuple for me to interact with. Now, that is a tuple, right? Because I didn't ask for something that directly represented a single object, right? I asked for a name and a quantity. It didn't give me back a cookie object. Now, I can take those two things and go get a cookie object, but in this case, I did not get a cookie. I just got a count, and that's boring. Make sense? Awesome. All right. So now we can expand that to order by. So here again, I'm just session querying cookie, applying the order by onto that same piece, and then telling it what I want to order by. And then I'm just going to print them out in ascending quantity, right? So 12 chocolate chips, 24 peanut butters, and no one eats oatmeal raisin, so there's like 100 of those. All right. We can do the same thing with descending. Here I actually import the descending function, the des function. Again, same thing, order by, and then desc, and then cookie quantity. You can, if you're so inclined, do cookie.quantity.desc. I like the explicitness of declaring up front, hey, we're going to sort descending from this, as opposed to like reading a whole statement and then like, oh, that's why it's upside down, right? Or this is why it comes out backwards. So this would print the same chart we saw a second ago, just backwards. And then the next thing that I want to do is we probably, so far we've been querying every single cookie. And even when we queried first, we still queried all the results and then just only took the first one of them. So we probably want to limit that scope down. So now I'm doing just that. I've got a session query going on for cookie, ordering by the cookie quantity, but I just want the two lowest cookies that we have, right? So in this case, it's chocolate chip and peanut butter. Does that make sense? Notice something interesting about this. There's no all, there's no first, there's none of that, right? In fact, I actually just stored this query in a query variable, right? If I was to string this, it would actually print out the SQL for that statement, right? So if you're debugging something in SQLAlchemy and you want to look at it, as long as you don't call .all or first or one of the actual execution methods, you can string the query and it will actually print out the SQL that's going to happen. So I've saved this as a query, and then I'm treating query in the normal iterator that I could do, session.query. This is the same thing as doing for cookie and session.query, whatever. I'm just doing it in a list comprehension. Does that make sense? Because we can do this, and because defining additional things onto a query is generative, which means additive, right? We can build conditionals in here, right? We can say, I can say query whatever, fine, and then if there's a flag for shipped, like we want to track if cookies are shipped or not, we could say if it's been shipped, then add these additional fields into my query, right? Or add these additional decision points. So because we can build out the query and add additional keep appending things onto it, like I've done here with limit or like we did with order by, because we can do that in a generative fashion, we can make all kinds of logic before we actually execute the query. Does that make sense? So we don't have to always have super complex queries. We can actually build them piecemeal at a time. And I can actually show you a function at the end of how we might do that. Speaking of functions, some things are just way more efficient to let the database do, right? So in this case, we're calling the function sum. So from SQLAlchemy, import function. Now, function is not a module. Function is a module generator. Anybody run into those in somewhere before? NumPy, SciPy is a lot of places where you see this. So what function actually does is it knows what the session is connected to from an engine perspective. So it knows what kind of database it's talking to, and then uses the functions that that database has available underneath the function module, right? So when we call func.sum, we are actually calling the sum function inside of Postgres, right? So when you string this statement, if you were to look at the SQL statement, it actually is like sum is in the main word. Yeah?
What would happen if you remove scalar from the end because it's going to come back scalar value anyway?
I'll show you just that. But let's talk about scalar since you brought it up. I was going to next. It's like you were planted or something. So scalar is an interesting thing. It returns the first element, whatever that happens to be, assume column in this case, right, of the first result. It'll also return none if there's no result. If there's more than one, then it blows up, right? It actually throws a multi-result value. So it will print the answer to the query, or the first column as a result of the query, none if there was no result, and then otherwise it just explodes. So in this case, we're getting a sum of all the cookies that we have on hand, just that cookie count, because we could have pulled other columns in this same thing, but get just the count of cookies and then printing that inventory count. What happens if I didn't call scalar? It's funny you should ask that. So here I'm counting the number of different kinds of cookies that we have. Sadly, we only have 3 kinds of cookies so far, and I'm calling .first on it. This is kind of the related neighbor of scalar. So in this case, I actually end up with a 3 and a 0. And you're going, why did you get a 0? You didn't ask for it but for one thing. What does Postgres actually return from a sum? What does SQLite return from a sum? Does anybody even remember old databases anymore? No, I'm just kidding. So underneath the hood, we actually get back like an actual result, yes, that is the count that we want. But then we get a specificity. I'm from the South. I can't say that word. Let's not even try. Specificity. Something like that. Whatever. So the really specific definition of how specific the result was specific or something. It basically tells us how accurate that result was, right? So 0 means there's no places. There's no additional decimals to consider. There's nothing else to think about, right? If there was a remainder, interestingly enough, this function .count would return, in this case, count isn't going to return a remainder, but if we did modulus or something and there was a remainder, it would throw that in that second column. Wouldn't actually throw the remainder there. It would just put a 1 there to let you know there was one. Because that, again, is totally useful and useful. All right. So interestingly thing about this, what button did I press there? Look how far I can go back. All right. So interesting thing about that wasn't labeled in any way, right? So I can define a label for that function count. Again, here this time though, I'm actually defining label on this function, right? So I'm telling it, hey, I want that to be called inventory count so that I can treat that like a normal, use it almost like it's an object, even though it's not, right? So it's basically creating a name tuple. So that I can access it that way. So here I can access record count .keys, which then tells me, hey, there is an inventory count key, and then I can print out rec count and then that key name, and it will give me the result of that, which in this case is 5. And I copied this code after I'd added some other stuff. That's why there's 5 versus 3, if you're wondering. Any questions about this part of querying? Because we're about to go in a different direction. So far, everything we've done hasn't limited the scope of any of the data that we're going against at all, right? We've literally grabbed every single cookie in the cookie table. It's only 3, so it's super fast. But we've literally grabbed every single cookie in the cookie table every time we've done one of these queries. We haven't really filtered any of them, right? We've aggregated and summated them or counted them, but we haven't filtered them down at all. Yeah?
Suppose there's a novel wafer and what decision you will make to create some sort of event.
Sure. That's probably a different question, and can I come back to that at the end? But it is a great question. It's easy to add indexes, but deciding how to do them is more of a database kind of question than a SQLAlchemy. But I will come back to that at the end. So let's talk about filtering by. So in this case, I'm still querying session.cookie, but now I only want to get the one that's named chocolate chip. And then so I select the first one of those that I encounter, and then print that record, right? So SQLAlchemy has a great confusion here in my mind. Filter by allows me to define a column right here, just the name of one of the attributes of cookie in this case. But where this gets confusing is, what if I select cookie and milk? How do I know what column that goes to? To me, that's very confusing. Once you've been playing with SQLAlchemy for a while, you'll learn that the primary thing that gets queried here is where this attribute must be. So I almost never use filter by, but I always show it because it shows up in other people's code bases. I don't use filter by because there is filter, and explicit is better than implicit, and filter lets me be extremely explicit. So this does the same thing the prior statement does, except instead of filter by, I'm using filter, and then I'm telling it specifically, this model, this column must equal that, right? So this doesn't get confusing as I continue to either add additional things into the query or as I continue to join additional things into the query, which we haven't looked at joins yet, but we will. Does that make sense? So prefer filter. right? Filter by gets confusing, particularly in a series of things where you might have some things that are filter by and some things that are filter. To me, that just gets really confusing really fast. Did you have a question?
Yeah, I was going to ask, SQL
Sure. Yeah. I just like writing cookie. I told you I was going to talk about cookies the whole time. I was not playing. Yeah, absolutely. You can alias whatever you want. It's a user object, right? You do whatever you want to do. As long as that user object, that's why that dunder table name is a critical component, right? That's the link. The primary key, and you can alias it whatever you want, right? If you alias cookie to cake, we're going to have to have throwdown. Like we're stopping right now and rolling. All right, so let's talk about clause elements. I was avoiding this a second ago when I called this a column, right? Cookie.CookieName. Cookie.CookieName is actually a clause element, this part, cookie.CookieName. What that is it's a column, but because of its position in the filter clause, we treat it differently, right? This allows us to take advantage of functions in the database like, right? Or is, or in, or contains, right? All of those things exist in SQL. We need a way to represent them in clause elements. So this one literally queries the cookies table anywhere where the word chocolate, love my old school Oracle, like percent symbols there, anywhere where the cookie name has chocolate anywhere in it, then return that as a result and then print it. And of course we have chocolate chip in the database, so that gets returned. There are a lot of methods on the clause elements, and it specifically rolls off the bottom of the screen because there are a lot of them. The ones I tend to use a lot are is, in, like I use quite a bit, and contains. Also pretty useful. There's a bunch of more of these. They wouldn't even fit on multiple slides. I just stopped when I got tired of typing. All right, so operators. This is kind of the next extension of that, right? So what I'm doing here is I'm querying a specific column. Still in the query column, I'm actually pulling in the quantity times the unit cost, right? So follow me? I'm casting that to a numeric. That's what cast is doing here. So I'm casting that to a numeric, 12 with 2 decimals, and then I'm labeling that inventory costs. Does that make sense? Everybody follow? Excellent. So cookie name, how much does it cost for me to hold this in my inventory? Let's not be kidding. Look at me. Nothing is staying in the cookie inventory. For result in query, then printing out the cookie name, and then I also have the inventory cost because I passed the label. If I didn't pass the label there, I would have absolutely no way to get that except by index, right? I'd be able to say inventory 1, right? Like it's a list or like it's a tuple, because that's what it is. Make sense? Yeah. Does the label persist? No. The label only exists as long as you are working within the context that you created it, right? So in our case, because result is the context of the record from the query, as soon as result is gone, the label is gone. Does that make sense? Now, I'll show you, actually I won't show you. There's a nifty thing called expunge. An expunge takes this piece of cookie you already have, or this record that you already have, disconnects it from the session, and leaves that name tuple for you to play with. So you could expunge it, and then it would stay. Does that make sense? But once you've done that, that's a pretty serious, it's a divorce. Stuff has gone down. All right. Operators, let's move on to conjunctions. So looking at conjunctions here, these are typically and or filters. In my case, I'm going to show you an or. So here I'm looking for a cookie that has a quantity between a 10 and 50, or that the name contains a result chip. So that gives me chocolate chip and peanut butter. If I want to do ands, interestingly enough, filter wouldn't actually require me to use the and underscore. Filter just will take multiple statements. Does that make sense? So I can actually say, forget the ors there. I could just have filter quantity this, thing this, and it would actually give me no results because neither one of those fall into that category. So filter can just take clause statements anded just by comma separating them, like a list. But if I want to do or not, then I need to explicitly define or not. If you see code I have written, I also explicitly define and. I'm really like it to be, when you look at the code, it's very clear what's happening, right? And sometimes when people are brand new to SQLAlchemy, they don't remember that filter can just and a bunch of filters together. Another thing that you can do is here we're defining a single filter, right? We've just got one .filter operation. I can actually go in here and define yet another filter, right? So I can say filter this thing, blah, 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 if shipped equal true, right? And then say filter where shipped equal true, right? I can tag multiple .filters onto the same thing. Again, it's the important part about being generative, right? Adding additional pieces one step at a time. Make sense? All right, updating cookies. This is the best if ever. I'm sorry, I'm sure you were expecting cats or something, but it's really cookies. All right, so let's talk about updating cookies. So here I'm actually retrieving the chocolate chip cookie record out of the database. Then I'm going to set the quantity, because I baked more cookies, of that up by another 120. Then I'm going to commit that and then print out the quantity, right? So pretty straightforward. All I did was made sure I had the object. Once I had the object and it was associated with the session, I then just performed whatever operation I wanted to do to change that. So in this case, I just said whatever the existing quantity is, 120. And then once I call session.commit or session.flush, if I'm trying to be efficient, that quantity is automatically updated. And every instance of, or every reference to that cookie object will be updated as well. Does that make sense? Pretty straightforward, right? This is one of the beautiful things. I don't have to query every time for this cookie. If I already had CC cookie hanging around, because I'd already touched it, I could just change the quantity, flush it, or commit it, and move on, right? But in this case, I'm querying it because I didn't have it already. Now, my least favorite thing to talk about is deleting cookies. But same very basic principle. The only difference here is that I actually have to explicitly destroy it. Okay, so like all good things in life, it's easy to create them, it's easy to do that, but if you want to destroy it, you actually have to do work. So here here's another good example of generative. I'm just creating a base query, then I'm defining my filter, then I'm taking that query and saying, give me the first one of those. Now, one is an interesting thing, right? I've shown you first, I've shown you scalar, I've shown you all. One is interesting. One queries all the rows, then raises an exception if anything other than a single value is found. So I'm being very specific. There must be one and only one peanut butter cookie recipe before we go delete this. Does that make sense? So then I'm calling session.delete. Session.delete is beyond destructive, for lack of a better word. No, it's super destructive, and it's pretty permanent. It's like go to tape kind of restore permanent. There's no like undo, whoops, I forgot. Once you call session.commit or session.flush after delete, it is gone from the table. Now, you still have that instance in reference, right? Like, so in this case, I would still have, when I got to here in this blank line, I would still have DCC_cookie, right? I could, in theory, add it back to the session, commit it, and it would be back in my database, right? But from this point forward, while I have an instance of it, it's not attached to the session. It doesn't exist in the database. Does that make sense? All right, excellent. Knowing that I ran the query the first time looking for one, I deleted it. Then I just wanted to really make sure it was gone. I don't know why I did this. But just to verify it was gone, query.first, because one would blow up when no result was returned. So query.first, okay, there was no DCC cookie. Make sense? All right, let's take a quick breather for just a second. Because the next thing we're going to talk about is relationships. And they are really a different look at all the things we've talked about so far. So digging into this, we're going to import only a couple of really important things. The foreign key one, because we have to define a foreign key between two related tables, a relationship to relate our objects, and this thing called a back reference that we can use to reverse that relationship. So I'm going to start by looking at a user model, and I'm only going to talk about the really important pieces here. Notice here, this is my user. I don't really have anything unique here. There's no foreign keys. There's nothing defined on this table, right? However, I'm going to define orders for those users, and there is stuff here. Here I have a foreign key, points to users.user_ID. See how this is a string and not an actual reference to that object, to that class? This is important. This lets this resolve at any time, right? There's no importance to the load order of my classes as long as that's in place. It's not actually until the relationship is evaluated that matters. If I was to put users here, it would have to exist from moment one. So users have to load first. So use a string. users.user ID. So this is making a foreign key reference from user ID in my order table up to users. Then the next thing I'm actually going to do is define a relationship with that user object, and then I'm defining the reverse of that relationship to be orders, and then here I'm ordering by, and that isn't really important. It's the same order by you've seen before. So again, foreign key on this table that brings in the user ID, then defining a relationship to the user model with a back reference of orders. What we have just done is for you to be able to say user.orders and get a list of all the orders associated with a user, right? Conversely, we can say order.user and get a list of or get a user that this order is associated with. Does that make sense? So the foreign key glues them together on the back-end side. This relationship and its associated back reference glues them together in the object side. And to go one step further, I have a line item model, which literally is the line items of an order. Here I have a foreign key to orders, a foreign key to cookies, then a relationship to each one of those. Make sense? There's one unique thing here as opposed to this relationship. There's no back reference from cookie. I don't really care about going cookie.orders and seeing every single order everyone's ever made for chocolate chip cookies. That would be like, I'd really need Mongo then. In this case, I just want to say, give me the one cookie, so don't return me a list of them because there's only going to be one cookie per line item. Give me the one cookie that's related to that. Make sense? So this was tying a list of line items back to an order. This ties a cookie back to a line item. So we need to persist these again. So when I call base.metadata.createAll, only the change things, only the change things are going to be added to the tables, right, to the structure. So when I call this, it's going to go create my users, my orders, and my line items, but it's not going to affect my cookies because cookies are precious. What was your question? Sure. So a foreign key is a type of constraint, right? It binds a connection or a relationship between two objects. There must be, orders must have a user. And to get to that user, we reference that when we're joining on the database side via a foreign key. Does that make sense? So it's a constraint, a limitation. While it might be able to be empty, we can define that if we want. It creates that constraint. There must be a binding there, right? So that's what the foreign key is, what I'm talking about when I say it binds those two together at the database side. It's the same relationship you'd have if you manually were creating database schema and you said foreign key. Yeah?
What's the query that's executed when you say give me all orders for all? Is it just join?
It is a join, absolutely. And we're going to look at some.
Join for you,
Yeah, it does a join for you in a super simple way. Like so easy the cookie guy can figure out how to do it. It's amazing. So let's look at defining a user. Same thing you've seen before, user, username, adding and then committing it, and then let's set up a session, or sorry, an order. So here I'm actually creating an empty order, telling it its user is CookieMon, because who else would be ordering cookies from me? Then I'm adding that order to the session. Now I haven't added any line items, I'm just wanting to get the order into the session now, right? So now order object associated with a user. See how I added the user to that? I didn't have to do anything weird. I had a copy of CookieMon from creating him, and then I just assigned him to the .user, right? That's going to create that. That's related objects, right? Now that I have an order, let's add some line items to that order. So here I'm going to get a chocolate chip cookie. I want to make sure there's only one record of that. Then I'm going to create a line item where the cookie is chocolate chip, the quantity is 2, where the extended cost is $1, right? Same thing for oatmeal raisin, same concept, and then I'm going to add the cookie to the line item. See the difference between these two? Here I explicitly said cookie equals CC. Right? To manually tie it back this way, I can also do the same thing. Line items have a cookie attribute, so line2.cookie equal my oatmeal raisin cookie. Does that make sense? Now the last thing I have to do, cookies are now associated with line items. I have an order with a user, so the next thing I need to do is get those line items onto the order that's already associated with that user. Does that make sense? Awesome. So to assign those line items is going to be a list, right? I'm going to append them. So here I'm appending line 1, here I'm appending line 2, and now I have everything all together. I have an order that's assigned to a user that has its line items that are related to cookies, and now I'm ready to commit that. So at the end of all of this work, I'm going to call commit one time. Everything will go into the database. Every foreign key will point to the right ID of the related instant or the related record, and it's all written to the database. I think that's pretty powerful because writing that by hand is really painful, right? I think this is why a lot of people, when they get into nested data structures, immediately want to go to document storage. And I don't blame them, because I think it's complicated to write raw SQL for those things. So let's look at leveraging those relationships when we're doing queries. Here I'm going to grab the order ID, the user.username, the user's phone number, the cookie name, how many of them, and how much it costs. Then I'm going to just say, query, join in user, join in line item, join in cookies. I can do them in any order. It doesn't care, right? I just know that I need those because I have the classes referenced up there. Then I'm going to say, I do want to filter, though, where cookiemon is the user who ordered. Give me all the records, and then print them. So here are the line items that would result as part of his order. Does that make sense? Again, the power of the generativeness. We define all the elements of the query that we want. We join in all the objects that need to join our principal object. Why do I don't have to add order here? Because it already exists here, right? Since this is my principal object, it's going to load that one by default. Then I just need to join in the related objects as well. Does that make sense? Yes, ma'am. Right. That would happen in an existing database, and where I defined columns earlier, I can actually go in and say column name that like references the column name in the table as opposed to the attribute name. So that would occur when we're first creating the database. Does that make sense? Excellent. So that's the line items that would come back from that. Let's look at one more example of using relationships. So here I'm grabbing the username. I just want to count how many orders they have. I'm performing an outer join. No weird like left, outer, inner. It figures that out. Just an outer join. Then I want to group by the username and then print each result. And thus I get Cookie Monster and his one order. So let's talk about where you go from here, because this was like a rushed intro, right? Like how much can you watch a fat guy exhale heavily like in an hour? This is extremely rushed intro, and I just wanted to kind of like pique the interest. Where to go from here? The biggest one is people say, I already have a database, and I don't know what to do with it, right? Like I want to get into SQLAlchemy, and I don't want to waste all this time remodeling all this data. So there's this thing out there called AutoMap. AutoMap's an extension. It ships native with SQLAlchemy, higher than 0.9, I think. You literally can point it at a database and say, make me classes, and it will go, all right, and it will make its best attempt to create the appropriate class for you. I can show you an example on the side. I have a nice IPython notebook I can demo real quick. But AutoMap is a way to take an existing data structure, map it directly into user classes that you can mess with. As easy as the stuff I've already shown you is, there's super simple support for geospatial queries. Yes, all the common things you're looking for. I can never remember the name of the Postgres thing. PostGIS, that's it. PostGIS, PostGIS2, everything that they support is available underneath SQLAlchemy. So any of the contains, within, without, bounds, all that stuff's available. Yes? You're talking about an explain?
Yeah.
Absolutely. So we can, at any time in these queries, until we call all or first or one, we can literally wrap them in string, like just str and then the braces, and it will give you the SQL it's going to execute. Another option that you have is where we define the engine back at the very beginning, you can actually say echo equal true, and it will print everything out. You will crush your machine, but it will print everything out, right? But it gives you the queries, and then you can take them and run them through explain or plan or whatever you want, right? Yeah. Doing it yourself is actually going to return a better result, because what you're more interested in is what's actually happening on the database side, not what little bit of connection stuff is going on in SQLAlchemy. So there isn't a ton of additional overhead in SQLAlchemy itself compared to any other thing that does what it does, right? What there is sometimes too steep of a learning curve, and just, to me, the documentation is a little confusing at times. But certainly what you want to do is drop to a string and then run that through whatever tool you're used to using. There is a profiler, and he's got a really nice write-up on it, but caveat emptor, you're going into a deep, dark database place. he is wicked in that domain, right? He is Mike Bayer. If you're not familiar with the name, he's the guy that created SQLAlchemy. He's wicked sharp at really low levels of database, and it gets scary down there fast. Yes? Absolutely. Sure. So that's a question I get asked a lot. One is I like the portability of SQLAlchemy. So I can take SQLAlchemy anywhere. It doesn't have to live in my Django app. It can run in a microservice. It can run inside Twisted. It can run as the back end of a CLI. Like, it can exist anywhere. The Django ORM, the moment I leave Django, I'm done. It's over. It's finished. I'm out of cookies. That's a bad moment. That's why I don't recommend. I tell people use the Django ORM for all the things that are connected in Django, and then once you leave that world of like, here's my auth models and that stuff, use SQLAlchemy. The other thing I like, and I didn't demo it here because we were specifically talking about the ORM, the core part of SQLAlchemy is actually far more powerful. It looks more like database queries, but it's extremely powerful, and you can do things like reflect data out of CSVs into directly into tables and things like that, and that's the part that Odo and Blaze and some of the tools from Continuum.io take advantage of. The slides are already up, bit.ly/SQLAlchemy ORM thing there, and I am done. I'm out of cookies and out of milk. Thank you very much. Oh.